Welcome back, grade 7 students. Now we're going to move on to section 5.3, functions, tables, and graphs. And our objective for today is to use function tables to generate and graph ordered pairs. We know from section 5.1 what ordered pairs are, and we know how to graph them now. But now what we're going to do is we're going to use function tables to generate points that we can plot on a coordinate plane. Okay, some of the key vocabulary terms are function, input, and output. Now, before I do anything, I want to draw a picture, and hopefully it will help you to better understand what functions are. Okay, I want you to think of functions as like a box or a machine or a robot or something that takes in an input. All right, so I'm going to draw this, and I'm going to say it's like a machine, a box, or something. This machine or this box, what it does is it takes an input. Okay, it takes inside of it an input. Like, let's say we drop, sorry, this is horrible. Say we drop something inside. Okay, so we drop something inside the box or the machine, the input. Okay, the function, what it does is it has to follow a specific rule. Okay, this robot has to follow a specific rule. So whatever input it receives, it manipulates the input and it produces, what it does is it produces an output. Okay, so we drop something inside the box. The machine, what it does is it follows that input or manipulates that input and it spits out an output. Okay, so we put something inside the machine. Okay, the machine follows a specific rule and it produces to us an input. So we put an output. So we put something inside. What we get is an output. All right. So what I want you to understand now is the input is always going to be our x values. Okay. What happens is we substitute our x value into the rule, and then it will produce a y value. What will help us to solve this or to figure out the output is a function table. Okay, so let's take a look. Let's start. Okay, so a function is a relationship in which the value of one quantity depends on the value of another quantity. A function can be represented by a rule or an equation. A function table can help you find the ordered pair values for a function. Okay, so like I said before, our input from now on is going to be called the x values. So whatever x values we receive, we input it into our rule over here. What is the rule for this? What is the equation for this function over here? Well, the rule is y equals 3x plus 2. So the y values are dependent on our x values over here. So whatever x value we put into our box, it's going to depend, the y value will depend on whatever x value is put inside of it. But it has to follow this rule. So how do you follow the rule? Well, it's very simple. All you have to do is basically substitute whatever the x value is in this case over here. So over here it's -2. So we take out the x and we substitute it with a -2 over here. So now we get a statement, a numerical statement, all right, with integers. So we have 3 parentheses -2 plus 2. So over here we have to follow PEMDAS, the order of operations. So we have a multiplication sign over here, even though it's invisible. 3 times -2 plus 2. So what must we solve first? Well, we must do the multiplication first. So we have to do 3 times -2 plus 2. Well, 3 times -2 is -6. So then we have -6 plus 2. And then now we just follow integer addition. -6 plus 2 is going to be -4. So with that, now we have an x value and a y value. And we know that an x value and a y value, we can make an ordered pair with an x value and a y value. All right, so over here, we're going to have -2 and -4. So that's going to be our ordered pair. And now, if we wanted to plot this on a coordinate plane, we can, because we know the x value and we know the y value. Let's continue. So over here we have -1. So we just substitute the -1. And notice how they put parentheses here. I love that. When you're substituting, always, when you're substituting your x value, always put the parentheses. It helps you to better organize your work. Okay, so we're going to put a -1 over here. All right, so now we have 3 times -1 plus 2. That means we must always do the multiplication first. So 3 times -1 is -3. So now we have -3 plus 2 is equal to -1. Okay? So, what's our ordered pair? Well, our x value is -1, And our y value is also -1. So this is another ordered pair. This is another point we can plot if we wanted to on a coordinate plane. Okay, so over here you'll see that they're substituting the value of 0. Okay, the x value is 0. So 3 times 0 plus 2. Well, what's 3 times 0? Well, it's just 0. Okay, and what's 0 plus 2? It's just 2. So now we have our ordered pair. 0, 2. 0, 2. That's our next point over here. Okay, the last one over here is we have 1. So we substitute the 1 over here. Notice how they put parentheses. We get 3 times 1 plus 2. So multiplication first. 3 times 1 is 3. 3 plus 2 is 5. So now we get our ordered pair, our x value, and our y value, and we get 1, 5. 1, 5. And these 4 points over here, we can plot them on a coordinate plane, and yeah. Okay. So let's look at another example. Oh, well, yeah, they have it over here. So if you look over here, you'll see the first point, -2, -4, is just down over here. That's the point over here. Then the next one is -1, -1, which is over here. And the next one is 0, 2. So 0, 2 is over here. And the last one is 1, 5 over here. So they graphed the resulting ordered pairs over here. Okay? So what did we do here? Well, we had an input. We put it inside our mysterious box over here, and it spat out an output for each input. So for each input, there's an output. And the output is dependent on the input. So -2 will produce an output of -4. -1 will produce an output of -1, and 0 will produce an output of 2, and 1 will produce an output of 5. Okay, and then we can plot it. All right, so the function, what it did here is it provided us with ordered pairs, and now we can plot them. All right, let's look at another example. So it says, find the output for each input value and graph the resulting ordered pairs. So very straightforward. Our rule, our equation. So how can we calculate y? We have our input, we have our x values, which are our input. How can we calculate y? Well, it's simple. We just substitute. We substitute for each input to get our output, then we create our ordered pairs and we plot the points. That's it. All right, so let's look at y equals 2x minus 1. So 2x minus 1. So 2, what is, I'm going to put our parentheses over here. 2 times -2, okay, minus 1. All right, so what will be our output? Well, we have 2 times -2 minus 1. We do the multiplication first. Okay, so 2 times -2 is -4 minus 1. -4 minus 1 is going to be -5. So our ordered pair is going to be -2 and -5. Okay, the next one we have -1, so same idea. We'll just substitute. We'll put our parentheses. It's very important. 2 times -1 minus 1. All right, so 2 times -1 is -2. Minus 1 should be -3. Okay, so we have -1, -3. Okay, next one we have 2 times 0 minus 1. Okay, so we get 2 times 0 minus 1, 0, 2 times 0 is 0, minus 1 is going to be -1, so we're going to have 0, -1. Okay, all right, so then we have 2 times, our input now is 1, minus 1, 2 times 1 is 2, minus 1 is 1. So our point is going to be, all right, 1, 1. Okay, and the last one is going to be 2 times 2 minus 1. 2 times 2 is 4, minus 1 is 3. So we're going to get 2, 3. And what we can do here now is we can plot the points. We have our points here. Let's just double check to make sure. All right, so 2 times -2, yeah, -5, good. 2 times -1 is -2, minus 1, -3, good. 2 times 0 is 0, minus 1 is -1, good. And 2 times, I'm good. And 2 times 2 is 4 minus 1. Good, perfect. And our points seem to be in line. Notice how the x values are going up by 1. And if you look at our y values, they're going up by positive 2. Okay, just to keep that in mind. It's not important in this lesson, but just keep that in mind. So let's look at the first point. -2, -5. So our first point will be over here. Then we have -1, -3 over here. Then we have 0, -1. So 0, we don't move across the x. We go down, -1. Then we have 1, 1. So 1, 1. Okay, and the last one we have is 2, 3. Okay, all right. Okay, so that's how we use functions. Okay, we just substitute our x values to produce our output, our y values, and we make it into an ordered pair, and then we can graph it on a coordinate plane. I wanted to show you just on the assignment, the homework packet that we sent. So it's the exact same idea over here, exactly like what we're doing. So if you were able to follow along with the lesson, then this assignment should be very easy for you. Same idea, same stuff. Just substitute your values, get your output, and for question 3, you'll have to just do one extra step in which you'll graph. So you'll substitute your inputs, okay, to the rule, produce your outputs, make the ordered pair, and graph the points over here. Okay, the next lesson in section 5.5 we'll be looking at linear functions, where you'll see in this example over here, if you connect the dots over here, you'll notice I haven't done a good job here, but if you use the ruler, you'd get a straight line, a linear function. But that's for the next lesson on section 5.5. Okay, thank you.